Alright, so let's take a look inside the volume curve field. Well, the beauty of this field is that it will provide you the access to follow the particles along the curve. This field actually considers a curve and it will allow the particles to move along the curve with the appropriate settings of the field. So let's do one thing. Let's first draw a simple curve and then we'll start creating the particles along with the volume curve. Alright, so let me just go inside the front view and go for the create curve. So under the curve tools we have the CV curve tool with the degrees set to the 3, and let's just draw a very simple curve. And just wanted to create some very interesting patterns over here so that we could actually see the overall result. And let me just give some small touch to the overall curve. And this is something very nice. That's okay. And here we go. So let's also do one thing. Let's drag this curve in the z positive or the negative directions to have some more interesting curves or the change in the patterns of the particles once they will start following this curve. That's nice, pretty amazing. So now let's do one thing. Let's create a very simple emitter. Let's go inside the FX and create the end particles. Under the end particle menu we have the create emitter, and this time I like to go with the I can go with the omni as well. I can go with the directional. So let's do one thing. Let's go with the directional so that it can pump the particles in the upward directions. Let's dip down the rate to 250. Let's use the speed with the value of, let's say, 2.5 and the random speed with the value of 1. Let's give a directionality as a y positive and a little spread, let's say 0.1, and create this. Alright, keep this thing near around to the starting point of the curve and press the C to actually you can snap the curve. That's fine. Let's change the background color for a while. And now if you play the timeline, you can see this is the very default and the behavior of particles. So because they are under the gravity, so that's why they are falling down. Well, let's say we can disable the gravity, ignore solver gravity, not a problem. And now let's do one thing. Now let's select this curve and go inside the field solver. Now use this option volume curve, which is just next to the under the volume axis. Alright, so hit the option volume curve. The moment you click this, you can notice that there's a very nice spiral bounding, or this is a kind of a spiral curve which is now encapsulating the selected curve. So this is basically the volume curve. Alright, so in the first impression you can see this kind of a section radius which we have is quite a small. So let's do one thing. Let's increase this. So we can do that if we go inside the volume control attributes and we have the section radius. Let's increase the value to a 2 and make sure that they shouldn't overlap. Over here you can see there is a kind of an overlap, but that's not a very big problem. Let's just reduce this to, let's say, maybe 1.75. Alright, nice. Now let's do one thing. Let's apply this feed to the particles. So for that we need to, and since it's already inside the curve, we just need to link the particles with this. So we can also use the dynamic relation editors. So just go inside the windows. Here we have the relationship editors, the dynamic relationships. Click the particles and use the volume axis field. So with this, now your particles are actually linked with the fields. So if I play the timeline, let's see the default behavior of the particles, and you can see that particles are somehow trying to enter inside the field, but now they have just left it because the settings are not appropriate at the moment. So let's do one thing. Let's go inside the field, and first of all we need to trap the particle inside the field. So for that, let's use this option, the trap radius, and which is somewhere inside the volume control attributes only. Here we have the trap inside. Let's use the value of 1, and we have the trap radius. Let's use a value of 3. So this way the particles will get trapped inside the field and they won't be able to exit the field. So this is pretty nice. Let me just extend the time slider. Alright, so now you can see particles now started moving inside the field, but this effect is not something like that much interesting because we can just take it a little bit more further. So let's do one thing. Let's start calling the other attributes which we have already learned inside the volume axis field. So we have away from the axis and along the axis. So along the axis is quite a good attribute. This will going to push the particles towards the along the field, and now you can see the particles have just getting some very nice speed. But this is something way too much fast for the particles to reach from one end of this field to the another end, and that was really very quick. So we can select the particles and move inside the dynamic properties, and here we have the conserve. We can dip down the value, let's say 0.9. Let's start experimenting with 0.9. Maybe we have to increase the value. And now if we play, you can see the particles are now moving a little slowly. It's not a problem. And let's do one thing. Let's start adding some more rotations, or the spinning around the line of the curve. So for that we need to select the volume axis field, and we can utilize this option, that is the around axis. Let's say we give a value of -10 or maybe 15. Now let's play the timeline. So now you can see particles are moving around this line of curve, and just creating a very nice interesting effect. Okay, so that was the around axis. Now let's do one thing. Let's also introduce some turbulence. Let me give a value of 0.5 with turbulence speed set to 0.5, and let's use some small and detailed turbulence. Let's say 0.1. And now if you play the timeline, you can see the overall behavior is slightly changed, but I still cannot see the turbulence. So let's go inside the volume axis field and increase the turbulence value to maybe 1.5 around, and let's also dip down the background color. And now let's play the timeline. So now I can actually see particles are randomly getting distributed, because they are under the effect of the turbulence. Let's increase the time slider a bit more. So now if I play the timeline, you can see the particles are now under the effect of the turbulence. They are moving around the axis also, and they are moving along the axis also. So this way we can just create a very nice and interesting motion. And the very good thing is that the particles have just locked themselves over here, and they are simply following the curve. So that's why the name has been given the volume curve. All right, and we can also play along with the other attributes, like we can still dip down the values of the particles, or we can also introduce some more, you can say, the random speed. So with this, the particles will get some more nice behavior inside their motions. So if you notice carefully, we don't use the speed random. You can see we have a kind of some repeated patterns over here, and they are actually quite noticeable. So we could get rid of them by increasing the speed random value, and this will really going to help you a lot. But we also need to be very careful that these particles have also try to skip. So let's dip down the value with the, let's say, magnitude 8 around, and let's also reduce the overall speed of the particles. So now let's see, and I think still the value is so high. Let's give it back to the 5, and let's say we increase the value to 3.5. Let's also dip down the spread to maybe around 0.010. And now if you play the timeline, now that's something nice. All right, so this is how the particles actually work with this. You can also bring some more twist inside the particles. For that we need to increase the around axis value, and that's really quite high. And now if you notice carefully, the particles have started rotating around the axis with more magnitude and more intensity. And let's also do one thing. Let's get rid of the turbulence, use a value of 0.5, and now notice the change. I just want particles to rotate around the curve, and that's very, very important. So this is something very, very nice. And this is something about the volume curve. Let's increase the time slider to a value of 350 and play the timeline again. So that was a quick preview of the volume curve, and I hope so that you must have understood the overall concept of this field. It's pretty straightforward, and you can create a lot of interesting effects with the help of this. And there's a nice pattern at the end of this field also. All right, so that was a quick look inside the volume curve. Now let's take a look at the summary of our overall module. So let's talk about the summary of our module. So the topics we covered include the n-particle fields and forces. So we begin creating the gravity fields, and we talk about the how gravity affects the particles by simulating an effect of gravitational pull. And we discuss about the gravity and the uniform field with respect to their mass. Then we talk about the air field, the drag, and the radial field, how their influence or these three forces can actually affect the particles' overall behavior and motion. Then we create an example of a suction where we use the Newton fields. and followed by the motion of a tornado, we constructed a simple tornado with the help of the vortex and the twist deformer. And then we created a turbulence field to affect the overall behavior of particles by creating a random 3D noise. And then we talk about the two interesting fields, which is the beautiful blending of volume emitters as well as the turbulence fields. So that's all for this module, and now let's talk about the MEL scripts and MEL expressions, and let's get started with the next one.